Hey friends, today's sponsor is Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed request traces from your cloud containers and orchestration software. You can track the health and performance of your dynamic containers, your apps, services, with rich visualizations and machine learning-driven alerts. Datadog's new cluster agent streamlines data collection from large container clusters and allows you to auto-scale Kubernetes workloads based on any metric that you're already collecting with Datadog. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit bit.ly.com/DatadogShirt to get started. That's bit.ly.com/DatadogShirt. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. And today I'm chatting with Matt Westcott. How are you, sir?
Very good, thanks. Thanks for having me.
So you're a web developer in your regular life, but you have a secret superpower that I think is quite amazing. You write for the ZX Spectrum. This is a 36-year-old computer.
Yeah, that's right. Yeah, it's become a bit of an obsession. Yeah.
Is it just that computer you're obsessed with? Or are you also obsessed with, BBC Micros and Commodore 64s and Amstrads?
I have a kind of a passing interest in the whole range of them, but the Spectrum was my first love, and that's been my main one. Mm-hmm. And I think the retrocomputing world, it's quite a big one, so I think you need a focus there. Yeah.
Describe this for people who are listening who maybe haven't seen one before. It is visually an unusual looking machine.
Yeah. So it was made by Sinclair, a UK-based company, and I think that Sinclair was always about sort of cost cutting and making things sort of miniaturized, and they set out to create a sort of computer that was kind of I think it's much cheaper than anything else that was on the market at the time. So this was a microcomputer. Kind of the whole unit was the keyboard and the computer itself, or a single unit, and it's kind of, I guess, about the size of a dinner plate, the original one, and rather than having a sort of proper sort of hard keyboard, it was all there's kind of a rubber mat that was, I guess, kind of like maybe old pocket calculators. So it's this very compact design. So this kind of little sort of shiny black thing, and then it would plug into your television set. And this was a really popular bit of kit, especially in the UK.
Mm-hmm. It is definitely a machine that I think we could look at and dismiss. You might see it at a thrift shop and you say, "Oh, this is just a fancy calculator," but it was extremely popular and went along for many years. It wasn't even discontinued until the early 90s.
Yeah, that's right. I think it's there's a few different models that came out, and I think as time went on, they started looking more and more like a real computer. But I think, it really captured the imagination of children learning to program, and there's a thriving games industry.
Is it something you'd add a keyboard to? I don't think I could imagine myself programming on this with the little chiclets. It's just little squishy gray keys. Seems like it would be exhausting.
Yeah, there were a few third-party sort of keyboards where you'd unscrew the original case and drop the motherboard in and get a better keyboard that way. Actually, the one that I started out with, it was the Spectrum Plus, which had a proper plastic keys, but it was still kind of the plastic membrane under there, so it was a bit still short of being a sort of proper professional keyboard as you'd think of it, but I think that I was spared the pain of the actual rubber one back in the day.
Mm-hmm. So there were 5 or 6 million of these out in the world, and it hasn't been in active. No one's been making these since 1992, but there were 40 software titles released in 2018. that's impossible. I mean, it wasn't all written by you. There must be a whole huge community of people excited about this machine.
Yeah, it's people are sort of interested in it as a retro thing, but well, in my case, I stayed sort of interested in it after it had died a commercial death, and it was just as a very niche hobbies thing. But yeah, in the last 10 years or so, it's had a real resurgence from the nostalgia crowd. And there's sort of lots of people, mainly sort of around Europe, who are developing for it. And yeah, it's a great community to be part of.
Do you write, like, I assume it comes with a basic emulator, but a basic interpreter, but you're not writing in BASIC, right?
No, I think it's pretty much all Z80 assembler.
Uh-huh. AT assembler. So what kind of processor are we talking about here?
That's a Z80. So it's kind of it was a derivative of the 8080 that it was cloned by Zilog. It was the creators of it, and yeah, so where one branch sort of turned into x86 and the modern PC, but the Z80 was a microprocessor that I think it still exists to some extent, but I think it had its heyday in the 80s.
Mm-hmm. Yeah, so you said Z, we say Z, the Z80 or Z80 from Zilog was something that came out in the early 70s, mid-70s. So this is a software-compatible Intel 8080. It's, like you said, it's a predecessor to the 8086. And does it, when you're on it, does it feel like a shadow or a beginning of the Intel processors that we're using? Do you think like you're looking at a piece of history, a piece of Intel history there, even though it's not Intel?
It's hard to say, really. I've never really dug into x86 assembly to the same extent that I have with Z80. But I think I guess the computer architectures back in the 80s, everyone was very much doing their own thing. So it's the Wild West in a way. No one was really sure what would become the final standard. So I think this is, the Spectrum and the Z80 are really sort of one out of many possibilities, really.
So you're in the UK, you're doing your web thing, you're designing and playing around with software, and as a hobby on the ZX Spectrum, and then you get a phone call or an email from someone at Netflix, and they just called you out of the blue. What happened?
It was through a friend of a friend on Facebook, actually. So I'm involved in it's a community called the demo scene. I should probably explain a bit about that was, but very, very briefly, it's a community of people doing like audio-visual artistic things on computers, new and old, and a lot of my Spectrum work is doing these little art pieces for this community, and it's a contact of mine, Chris Milray, otherwise known as Citrix. He just sent me a Facebook message saying that I've got this. There's a producer from a TV show that you've definitely heard of, and they're interested in getting some Spectrum programming done for it. So I thought, well, this is definitely up my street. So at this point, I didn't know anything about what the show in question was, but they put me in touch, and I sort of signed the NDA, and I started getting the small fragments of information about the show turned out to be Black Mirror, and I got this very basic outline of what the show was going to be about, namely about a programmer from the 1980s creating video games for the Spectrum, and they were keen to, as a kind of Easter egg, to take some of the fictional programs from the show and make them into actual real world Spectrum programs.
So you only, like you said, you had pieces of the information, and even until it probably came out, you still only had fractions of what was really going on, right? Like they didn't like say, here's the script. What do you think? They said, here's a theoretical video game that exists, as mock-ups within the game, within the show. The game didn't exist, right?
No, so they created mock-ups of these games in, I think, Adobe Premiere. So everything that is actually seen in the show is it's a very clever mock-up of the Spectrum graphics, and so I had these sort of 10, 20-second clips of the games. Just the snippets that you see in the show, and I was tasked with making that into a real Spectrum game.
Wow, that'd be challenging. Someone, rather than designing the game, your specification was like, here's a Adobe Premiere thing, or here's a Flash game that's not really the game, and from an angle or whatever, like go and figure this out and go write us a game.
Yep.
And they weren't kidding. They wanted it written for a real ZX Spectrum.
Yeah, that's right. And to their credit, it was a really well done mock-up. Right, so a lot of, like, when people are trying to create something in an 8-bit style, they'll just sort of take some like modern video game graphics and just scale it down. But they'd sort of taken the time to figure out the correct screen resolution, and right down to the little graphical quirks that the Spectrum had, where it's called color clash, where if you've got one sprite of one color moving on top of another one, then the color will bleed from one sprite to another, because there's limitations on the number of colors you can have in a particular bit of space. And
oh my goodness, they really did some research.
Yeah, there's definitely people on the production team with a real love for the Spectrum.
Wow. Okay. The image resolution of a Spectrum is 256 by 192. This is the kind of thing that we imagine a resolution that we'd see like on a tiny, tiny OLED screen the size of your thumbnail. But this is, and it also has a kind of a grid overlay with quite a lot of limitations in size, limitations in color, not to mention the color clash that you called out.
Yeah, that's right. So yeah, you've got so you have the basic 256 by 192, and that's kind of just a monochrome image with the color overlay on top, and the exact limitations are within every 8 by 8 pixel square, then you can use 2 colors out of a palette of 8, and you can also have the whole that square designated as bright or dark.
Oh wow, that is complicated, and they're basically trying to do all of this because of limitations, right? This is all about constraints. That's probably why people find coding for the Spectrum so fun, is that this is an exercise in constraints. What can I do with so little?
Yeah, exactly. So the screen restrictions that comes out of the just memory limitations. I think you had 48 kilobytes of memory in the entire thing, and by having this mostly monochrome screen, that means that only takes up 6K. And but yeah, the working in those limitations, it's that's really what appeals to me, and it's. In a way, it's kind of a bit of escapism from working with computers in my day job, because you can really understand the machine at the really low level. You're not working at the top of this stack of abstractions. It's some, you can get your head around the entire architecture of the machine just in your head.
There's nothing hiding. There's no layer of abstraction. There's no C runtime. There's no JavaScript. It's just you and a piece of hardware and some registers that you can play with. Yeah,
exactly. And that it means that you're kind of free to kind of invent ways of doing things, trying to you use the Z80 instruction set in creative ways to squeeze out sort of a bit more performance, sort of push more pixels than you normally would be able to, and just by sort of doing things in sort of non-standard ways. So yes, kind of breaking the rules of structured programming. So yeah, it's really a sandbox where and anything is possible, really.
And when you say pull out more performance, it might seem odd for people to listen and think like, well, what kind of performance are you going to get from this? But that's really the essence of the whole demo scene, is to see what can I do with smaller and smaller constraints? What can I do in 3K and 4K and 2K?
Yeah. There's all kinds of different limitations, like the size limitations, working with limited hardware like the Spectrum, and yeah, it's I say it's kind of in a way escapism from what you would do, what you'd be working on in some more mainstream programming.
Hey folks, you're a very good developer, probably. Regardless, you do write bugs. That's unavoidable. What is avoidable is wasting time trying to track down the cause of those bugs. Sentry.io provides full-stack error tracking that lets you monitor and fix problems in real time. You can see the severity and the scope of the error, get immediate access to the stack trace, connect the problem to the commit that caused it, and fix it without delay. Sentry, it's a name so common that they have to include the top-level domain in their advertising to make sure you remember it. Sentry.io. That's Sentry.io. Open source, full stack, web apps, native apps, mobile games, smart oven mitts. If you can program it, they can make it far easier to fix any errors you encounter with it. Your code may be broken. Let's fix it together. Visit Sentry.io. Was there anything when you were writing this that you thought wasn't possible, or was it a straightforward game as Spectrum games go?
In this case, it was fairly straightforward. I think normally when I'm doing demo scene things and trying to push the limits, then it's because I'm the one that's deciding this is what I'm going to create, and this is my plan of attack. It's kind of a bit of a different approach when I was given something to create, and so that was kind of a bit more constrained than I would usually be if I was left to my own devices. But,
how much time did you spend on this? Is this something you bang out in a weekend, or is this many weeks of work?
I think it was it was mostly after hours in my evenings. I think it was maybe 2 or 3 weeks of evenings.
Oh, that's not too bad.
Quite a lot of it. It was there's a few things that I'd not really I'd taken this approach before. Usually, if I'm doing the demo scene things where it's very sort of focused on just this specific visual effects and everything, you're able to really plan out sort of exactly what's happening on screen at any moment. But with a game, because it's always variable how much action there is on screen, then it's that ended up being kind of a different approach, and so I had to sort of rethink how to deal with clearing and reprinting sprites and making sure that it didn't clash with how the screen was updating. And so there was quite a lot of sort of rethinking the way I usually do things in that respect.
How did people load their applications? There's no SD cards. There's no hard drive. What is the input-output of a Spectrum?
Well, back in the day, at least, it was sort of cassette tapes. You'd have these sort of tapes with the 5 minutes or so of these high-pitched bleeps that sort of encoded the binary data, and since, as I say, the Spectrum, it was very much a cost-cutting thing. The idea is that you would just take your tape recorder that you had just lying around the house and just plug that into the Spectrum, and you would hit play and wait 5 minutes for this whole thing to load into the into the memory, and at the end of that, you would have the game. And I think one thing that was quite unique to the Spectrum, I think quite a few of different microcomputers they used cassette tapes, but the Spectrum was kind of unique in that you actually heard these bleeps while it was loading, and I think there's some speculation that was more a hardware bug than something intentional, but yeah, it did mean that you had this very anyone who was loading games on this thing, it would be a very familiar sound, this sort of beep, 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 sort of sound.
Sometimes when I'm trying to explain how this works, I use the idea of modems. Is it almost like a one-way modem? It's almost like you called, like the computer called somewhere and it played back to them, except it's only one way. It's coming from the tape directly into the device.
Yeah, I think that would be an accurate way to describe it. Yeah.
So it's whistling and it's doing its high bit and its low bit based on the tones. That was how it was done in the 80s, but you were writing this in a text editor. How did you go from a text editor to a tape, and how did you deliver this to them?
So developing it, I'm mostly, pretty much exclusively using an emulator on the PC, and there are sort of utility programs that deal with the file formats with the emulator that kind of simulate the tape image and can convert that to just a WAV file. I'd say the development I do is pretty much exclusively on emulators. It's just a more convenient way of working, and yeah, but they do have support for loading and saving as audio files or various disk systems that existed for the Spectrum over time.
So you do the work on a modern PC, you test it in an emulator, you save it as a .tap or .tape file, and then you can also export it as a WAV, effectively a sound file that could then theoretically be put on a real tape if someone wanted to load this on a Spectrum?
Yeah, exactly. Yeah.
Okay. Are Spectrums hacked such that you can feed stuff into the Spectrum faster than a real tape? Or if you wanted to go and do a final production test on a physical real machine, would you really record to a tape, play it back, and wait 5 minutes?
Well, over time, there's been plenty of more advanced storage systems for the Spectrum. So these days there are SD card add-on interfaces, and so it's most of the time I think you just take these emulator files, just drop them onto the SD card, and there's custom firmware for the Spectrum that can load straight from that. But yeah, over time, this is something that's evolved quite a lot for quite a long time. Like in the 1990s, I was working with floppies, and it's something that the technology, the Spectrum has been catching up with modern hardware in its own way.
It's so wonderful to see all of these older pieces of hardware get little hacks and little mods. I've got a Nintendo Wii, and they can load off of the SD card. I've seen a USB port added to a Gold Star 3DO. Everyone wants to make it nice and easy so that someone can get involved in retro computing or retro gaming.
Yeah, it's when I think back to the development process before I moved on to emulators, and the thing with developing in assembler is that if there is a bug, then there's not really any way of just stopping with an error message and then going back into like finding your bug. It's that it would just hard crash the machine. So, in the worst case, that would mean that you'd have to spend so 5 minutes loading everything from tape all over again, or well, this is again where the more modern the hardware accessories over time really helps. I had a disk system where you could save a snapshot of the memory to disk before running a program, and then if it crashed, then you'd still be able to load that snapshot out. But I think being able to do everything instantly through the emulator, just have a single command that can compile everything from a text file and then just fire up the emulator, I think it's a real luxury compared to what we used to have.
Yeah, watching the character in the Black Mirror Bandersnatch show, there was just a lot of him staring at the screen with his head in his hands, which I feel like, as someone who developed software in the 80s, that really represents, very, very accurately what it felt like. There was no internet. There was him, a stack of books, and he was staring at a screen looking sad for a very long time.
Yeah, and I think it's worth mentioning that I think they used a bit of artistic license in the show, in that they showed him programming in BASIC.
Indeed.
But, I think that's kind of acceptable artistic license, with sort of making programming look how the audience might expect it to look. Yeah,
indeed, it would have been much less glamorous if we'd been doing it in assembler.
Yeah.
Where did they hide this then? So how did people find this game? So there's, they could have just mocked the whole thing up and called it a day.
So it's so they stashed this. It was at the end of it was one of the endings, because the actual process for getting to this particular ending, it's kind of a bit vague, but there is the scene of the main character. It's a kind of callback to an earlier scene where he's on the bus listening to music on his Walkman, but rather than putting a tape of music in, he sort of puts his demo of his program in and starts listening to these high-pitched bleeps. And it's people. As this is a kind of a very distinctive sound to a small fragment of the audience. So I think once people discovered this scene, I think there were there's a certain portion of the audience where they had that sort of light bulb moment of, I know what this is. And so they just found the right setup to take that audio and feed it into the Spectrum.
It's so wonderful that in 2019, in modern television right now, you realize that if that had just been honestly screeching and nothing had been hidden there, I think we would have all been disappointed. And it's so wonderful that people like Black Mirror or Mr. Robot puts the work in and hires people like you to do fun Easter eggs like this, because it helps us engage in such a deeper way with the medium.
Yeah, it feels kind of amazing to me that I'm getting this paid work doing Spectrum development in 2018, 2019. But it's I think obviously the creators of the shows, they sort of grew up in this era as well, and there's obviously some real passion for the old computers there, and it's been great fun to be dragged along with that enthusiasm.
So were there two programs written? Because the screechy noise in Bandersnatch demo isn't actually the game, right? Because that would have required a lot more audio. Is it a QR code that points to the game?
Yeah, that's right. So that's one bit of the briefing I got from the producers was that, okay, whatever we do, the bit of audio that plays in the show, it can't be longer than 1 minute. So obviously that would have been quite tricky if that had been the entire code of the game. So their suggestion was that the audio that you hit that plays in the show would just display this QR code, and this was at the point where I was able to sort of upsell them a bit and said, well, since I'm used to doing these like visual effects on the spectrum, I thought, well, rather than it just displaying a static QR code, then how about I sort of add a bit of like VHS style glitching and to kind of make it a bit more of the Black Mirror ambience, and so that was a lot of fun to do, just to try and create these kind of fake VCR noise effects. And
how long does it take if you did the entire game? You said 3 or 4, 5 minutes of audio?
Something like that, yes. It's this is one place where we can take advantage of the sort of last sort of 20 or 30 years of Spectrum development. So there's people have come up with sort of compression systems that where you're compressing things on the PC and then unpacking them on the Spectrum. So things are sort of a bit more efficient than they would have been for someone making this entirely on the Spectrum back in the 80s. But I think it would have been something like 2 or 3 minutes maybe for the nohzdyve game.
Mm-hmm. And the nohzdyve game is something like 13,000 bytes, and the average transfer rate is 300 baud, or about 38 bytes per second. So you can figure it would take a while.
Yeah, something like that, yeah.
Fantastic. So people can follow you on Twitter at Twitter/gasmanic, MANIC. I'll put links to this in the show notes. And you can go to tuckersoft.net and play nohzdyve, NOHZDYVE. And hopefully they can go out there and Google and learn all about the exciting ZX Spectrum community that I hope has been re-energized by this bit of nostalgia that they inserted into the Black Mirror episode.
Yeah, it's been a lot of buzz in the Spectrum scene as well as in the Black Mirror fan scene. So it's been really sort of exciting to see that blow up over the last few weeks. Yeah.
Fantastic. Thanks so much, Matt Westcott, for chatting with me today. This has been another episode of Hansel Minutes, and we'll see you again next week.